Okay, this is our circle question on our December mock. Please pause if you want to have a go at the question first. Okay, lovely classic question. Find the centre, find the radius. So generally I write the question out again, but putting the x's together and the y's together, and I will stick the 9 on the other side. So now I just look at this and complete the square on this. So I've got x minus 3 all squared minus 3 squared added to y plus 5 all squared minus 5 squared equals minus 9. So I've got my 2 squareds bit, and I've got minus 9 plus 9 plus 25. So that's just going to equal plus 25. So therefore the centre C is going to be 3 minus 5 because it does the opposite of what you've got there, and the radius is 5 because it's a square root of 25. Find the line y equals kx, where k is a constant that cuts in 2 distinct points. Okay, so if kx, so if I've got my circle and I've got a line chopping it, if it's 2 distinct points, we need to solve it simultaneously. So I need to sub in kx for wherever I have a y. Now, if I was feeling brave, which I probably should, but I'm not, I should, but it's just in case you're not sure that what you've done here is correct, you don't, compound the issue by subbing it into your answer. So what we're going to do is we're going to sub it into the original. So I've got x squared plus y squared, which is kx, minus 6x plus 10 lots of kx plus 9 equals 0. And k squared, that's going to be k squared x squared minus 6x plus 10kx plus 9. Now, 2 distinct points, it's screaming discriminant. So b squared minus 4ac has got to be greater than 0, not greater than or equal to, just greater than 0 for 2 distinct points. Okay, so you've got this equation that is where, so this equation here is the equation to find the unique x value of where your circle and the thing crosses, because those x values are the same, so you know you're going to get it. And so you've got a quadratic giving you those 2 solutions. So this is true, the discriminant does work, it is true. So we need to get our equation in the form of finding our a, b and c. So we're going to look at our x squared and say this is 1 plus k squared, lots of x squared. And then I'm going to move this around and say this is plus 10k minus 6 lots of x's plus 9 equals 0. So then that's my a, that's my b, and that's my c. So 10k minus 6 all squared minus 4 times a times c is greater than 0. That's what I'm trying to do. Okay, so I might need a bit more space by the looks of things. Get that one smaller over there. That's the first bit we did. And then I'm going to move this. Might make it a little bit smaller. Okay. And then move that up a bit. Right, okay. So multiplying out the brackets, I've got, so, and if you need to, please do it. Don't think you can work it out without doing this. And I'm going to bring the numbers to the front because this always mucks people up. Oh, how did I get 39? 4 9s are 36. Right, 10 times 10 is 100k squared. Plus 36. And I've got minus 60k and minus 60k, and here I've got minus 36 and minus 36k squared is greater than 0. So let's join the thing. Oh look, plus 36 and minus 36 disappear. I've got 100 minus 36, which gives me 64. 64k squared minus 120k is greater than 0. Just going to take the k out because I can't be bothered to take anything else out. So therefore k is greater than 0, or 64k minus 120 is equal to 0. So so k equals 120 divided by 64, which is the same as 15 over 8. Okay, now I can't say that bit. I shouldn't have written that there. Okay, these are the solutions. We have a quadratic that we want to know where it's greater than 0. This is my x-axis, so it's greater than 0 in two distinct places. So that side and that side. So this is 0 and this is 15 over 8 because this is bigger than 15 over 8 is bigger. So therefore this is true when k is less than 0, where k is greater than 15 over 8. That is supposed to be 15.